I'm Ian Whitney. I'm with the ASR Custom Solutions Group. Today we'll be talking about external data and events, specifically how my team has dealt with external data over the 10 plus years of our existence. So how does ASR deal with external data? What sort of external data do we deal with? It's mostly PeopleSoft, right? That's the source of data on campus that we care about. ASR mostly deals with student data. That data lives mostly at PeopleSoft. And we use it mostly to build web applications, but in some cases we'll use it for other things, I'll just say. I wanted to give a quick introduction, and this is probably wrong, but I don't see anyone from the DBA team to tell me that I'm wrong. Cool. That this is, well, Mark can probably tell me that I'm wrong. My understanding of the PeopleSoft database architecture on campus right now. You have live PeopleSoft. The data from live PeopleSoft is copied daily into this weird environment called Data Warehouse Snap that are kind of the same, but kind of not. The legacy data warehouse, I should say, not the new one. That's a whole different thing that I'm not even going to talk about. And then off on its side is the Oracle Hotel. And I put boxes around these to indicate something that's going to be important later on, which is that if you've got a bunch of databases that are within a box, then those databases can talk to each other fairly easily. If you've got databases that are across two boxes, that's when I start talking about external data. Having those two databases talk to one another, share data, it requires a database link and some other technical solutions that we're going to be talking about today. If you're dealing with Oracle on campus and you're not Kirk and probably HST, you have databases in Oracle Hotel. That's where all of our application databases live. Whereas all the data we want is in live PeopleSoft. I'm going to talk about a lot of different techniques we've used, but I'm going to have one kind of example problem that we're going to go through. And we're going to look at all of those solutions and see how it works for that example problem. And this is representative of the sort of work that ASR Custom Solution does. We want an application that was going to show students their current class enrollment. And we want to be able to look at that students' enrollment data and see if it changes over time in such a way that we should alert their advisor. Hey, this student just suddenly dropped all their classes. You should probably find out what's going on, right? A+ does some stuff like that. We are not responsible for A+, by the way. And to talk about that solution, this is really talking about two different aspects of external data. One, I think we're all very familiar with, which is state, which is the data as it is now, right? This is what we think of when we think of databases. Select star from this table. It shows you a bunch of data. That is the state of the data. But there's another important thing here that are part of databases that we haven't really thought about a lot, and that is events, which is an alteration of the database's state. So anything you do to a database that changes the data within the database, inserting, updating, deleting, that is an event that happens in the database that changes the state. So if you think of an event, it's just anything that changes the state of data in the database. So if we're looking at student enrollment, we're looking at a table that I made up. This doesn't actually exist in PeopleSoft, called student enrollment. It does, but it's called something else that's way harder to deal with. But let's just pretend there's a student who's enrolled right now in two classes, small group communication and creativity intelligence. We can also look at how they've chosen to be graded. One they've chosen to take A through F, and the other one they've chosen to take pass-fail, although for some reason the U calls that SN. I just called it pass-fail because that's what everyone else, that's what we should call it. And that's cool. This is, we know what a student's taking, that's their state. But how they got to this state is actually a more interesting story. Let's say that student registered for small group communication, they waited, and then they registered for creativity intelligence, but A to F. And then they registered for organic chemistry, A to F. And then they changed their organic grading chemistry to pass-fail. And then they changed their grading for creativity intelligence to pass-fail. And then they dropped organic chemistry entirely. That's a more interesting story. And it tells me actually that maybe the student's struggling a little bit with figuring out their class load. And it also tells me that organic chemistry sucks, right? Like if there's one course on campus that most students have taken more than one time, it's organic chemistry. So I think that's an interesting list of events that we might want to tell the advisor, hey, this student seems to be having some trouble with their enrollment. And the fact that they're only taking two classes is also kind of unlikely. So if we want to kind of solve our problem of showing a student their state and also being able to alert an advisor when certain interesting events happen, we kind of have three metrics for success. The first one is we want to show the student accurate data. If they go to this web page, we want to show them their current classes. We don't want to show them the wrong classes, because at that point students get really mad and don't trust the tool. We also want to be able to look at changes to that data and notify the advisor when certain events happen. And it would be great if we could be resilient to if PeopleSoft is down, it would be great if our application was still up. I'm going to call that a bonus, right? That's not a core part of our problem. If we can get the first two things, great. If we can get all three of them, even better. So this is the kind of example problem that ASR has been solving with external data for at least 10 years, Chris, I think, right? Yeah. And we've done it a lot of different ways. And we're going to kind of go through some different solutions and how we've done this. And I'm going to talk about them chronologically, but I think it's really important to say that all of these work, right? Every single one of these things I'm going to talk about today is in production right now, and it is running a production system. Yeah, we have like 5 different solutions for this, running production systems. Maybe that's a problem. But the point here is that all of these work. I think if we look at a series of chronological solutions, we just assume that evolution is at play and each one is better than the last. And that is not the case. And I'm going to be talking about pros and cons here of the different solutions. And you might say like, oh, this first one is exactly what I need. Yeah, there's that con there, but that's not relevant to me. And so don't look at these as like we're doing thesis, antithesis, and moving towards some sort of like ideal communist goal, right? And the first one is an extract, transform, load, or ETL process. We do a lot of ETL on campus, right? That's how you move data from one database to the other. And we've done ETL a lot of different ways over the years, but it all boils down to basically this. You select data from a table, you monkey with the data a little bit, you put the data in another table. Right? That's the essential extract, transform, load process is that. And we've done this to take data from Oracle, from the data warehouse or snap tables, monkey with it a bit, and shove it into MySQL. We've done it so that we take it from Oracle and we put it in a different part of Oracle. Sometimes we just take all the data, sometimes we take some of the data, sometimes we monkey with it a lot, sometimes we don't monkey with it at all. It all really boils down to these 3 steps. And there's some pros to ETL. It's a very simple mechanism. The idea of like, okay, I'm going to select some data and I'm going to insert it over here. That's a very easy abstraction to grok, and you can really see how all the pieces are working. It really lets you transform the data into the shape that you need. PeopleSoft doesn't index a column you want. Cool, index it the way you want over here. PeopleSoft includes like a million columns that you don't use and that PeopleSoft doesn't use for some reason. Just don't include those. It's cool. If you're thinking of Andy's talk from last month where you can have much faster queries by having a smaller block size, you could do that by just selecting the 3 columns you need instead of the 48 columns that PeopleSoft has. And you're not restricted to Oracle now. You can take that external data, that state, and put it into any relational database, or non-relational, I guess, database that you want. There are some cons to ETL. It can be slow. For example, we had a query that was looking at class scheduling data, and just due to a misconfiguration of a join in that query, it took 7 hours to extract data from the snap to our thing until Jeff Aspinall called us one day and said, can you stop? And we said, oh, yeah, we'll take a look at that. And I think we got it down to like an hour, right? Like we fixed the query, and now it's just an hour. And the downside is if ETL fails, it can put your personal data into just an unknown state. And we've seen like, well, we still have data from 3 days ago instead of yesterday's data, or we have no data, or we have some data, right? These are not things that are easy to catch operationally, and well, no data is fairly easy to catch, but it can just put you into kind of a weird state. And if we look at ETL as kind of our metrics for success here, does our ETL process provide accurate data? And I'm going to say kinda, because we at this time, for most of our ETL processes, are looking at the data warehouse snap. So that is taking data from yesterday and putting it into an application. So our data is at best a day old. Could we look at live PeopleSoft? At the time we wrote this, we couldn't. So it's still day old data. Can we do event-driven actions? So if a student changes their classes, can we notify their advisor? Kinda. We have tooling that keeps the data from 2 days ago and the data from yesterday, and then can diff them, right? So if that change happened over the course of 2 days, you can get that high-level 1-day diff of data. But if the student did things 10 seconds apart, nah, you're not going to see that. Can you work if PeopleSoft is down? Yeah, you certainly can. You've taken the data out of PeopleSoft entirely. You were dealing with the warehouse to begin with. PeopleSoft being up doesn't affect you at all. But again, weird things can happen if your target environment or your extraction environment goes down while you're doing that extracting. After the ESUP project, which is a while ago now, 6 years, the opportunity opened up for us to start doing live querying of that live PeopleSoft environment, that kind of holy grail of where the actual live data is. So we started doing a bunch of that. This is an even simpler thing to talk about. You just query the data. Now remember those boxes, because we're dealing with data that's in a different box, we have to use what Oracle calls a database link to get from our application database to live PeopleSoft. We can't just easily query the data without a database link. Database links are a super great technology that can also totally break your application and suck a lot of ways. I asked Andy about this last time. It's like, hey, we should have a talk about how to use database links and have them not be terrible. And he was like, eh. Because the problem is, right, you're now taking some arbitrary amount of data and transferring it over the network. And networks suck, right? They drop data all the time. They're slow. And if you start selecting like the entire student enrollment data from live PeopleSoft, that goes back to like 1902 and is gajillions of rows. And it's also really wide, going back to the blocks thing. And it starts trying to bring all that data into your database so it can do like a simple join. Oh, your application goes to hell. Like you're just out of luck. And you can't necessarily fix it with a database link. There's some tricks you can use, and if you're really careful with the way you do this, then you don't have that performance problem. But you can put yourself in a world of hurt if you're just doing this and joining random tables across the database. So what are our pros here? We're querying live data, so we know it's up to date. It can't really be anything else, right? So you have that guarantee. There's some cons of dealing with live PeopleSoft directly. The data warehouse pre-joins a bunch of tables for you. So if you want to deal with like class data in live PeopleSoft, that ERD I think prints out to something like this. And in data warehouse, it's just a table. Cool. Yay. I don't have to do all those joins. Non-production live PeopleSoft goes down for maintenance regularly, and if it goes down, your database link is dead. You can't do anything. Production PeopleSoft doesn't go down that often, but if you have a QAT environment that your users are using for testing, and it goes down for a week, and they tell you about it a day in advance, not that this would ever happen, and then suddenly your QAT environment is fairly useless, right? And then there's a big con there, database links. They can just totally mess with your performance. But how does this work for our metrics of success? Do we have accurate data? Yes. And if that's your goal, if that's your one and only goal, and you can deal with those other cons, you're good. Can you do event-driven actions? No-ish. I'm going to put an asterisk there, and I'm going to get back to that. Can you work if PeopleSoft is down? No, not at all. You just can't. So what if we take our two approaches so far and combine them? We have live querying that lets us query the data as it is in PeopleSoft now, but when we query it, we ETL it to our own local database. So the process there is you have ETL code that runs those live queries. So say looks at student enrollment and on some sort of schedule, a schedule that you control, it takes the results of that query and it shoves it into a materialized view into your application database. At this point, when your application is querying tables, it's querying the local copy, the local materialized view, and you can tune those ETL jobs to run as frequently as you want. Oracle, I think, lets you get down to within seconds of running ETL jobs. Sometimes the DBAs get mad at you, though. If you do that, we had everything running at a minute, and they said, can you not? And so I think most of our jobs now are every 5 minutes. So we're taking this process now and combining our two techniques, and we have live data, but our application is no longer querying data over that database link. So we no longer have that performance hit. So it removes the huge con of the database link. And your data is near live, and as near as you can configure it to without angering the DBAs, right? You still have the same con of our previous live PeopleSoft, which is that you don't have the convenience of the data warehouse tables. And you're now introducing a whole new layer there, which can be really hard to reason about the topography and freshness of your data. All right, this is a materialized view, and it refreshes every 5 minutes. And it's coming from here. It just adds an extra layer. And I will side note here that we have had an ongoing bug, we think with Oracle, for 2 months now, with one of these materialized views that mysteriously just hangs every time we try to refresh it. Don't know why. We've been trying a lot of work with the DBAs. We cannot figure this one out. So this is a great approach, but you might hit this weird Oracle bug that breaks all of your stuff. But let's look at for metrics on success. Accurate data. Is it up to date? Yes, depending on your ETL frequency. If you tune your ETL frequency to be once a day, you might as well just be talking to the data warehouse. Can you do event-driven actions? No, asterisk, we'll get back to that. And then resiliency. Can you work if PeopleSoft is down? Now you can, because your application isn't talking to things over a database link, it's talking to local tables. You no longer have to worry if PeopleSoft goes down. You have whatever your most recent copy that you got out of that ETL locally, and you can continue to churn on until PeopleSoft comes back up and your ETL kicks back in. You might want to have something in your application that says, hey, our data is stale, but you don't have to really worry about PeopleSoft going down. So I've had this no asterisks, and we're going to talk about a very Oracle-specific technology. Everything I've talked about so far is not Oracle-specific. You can do this in any language or any relational database. This is very Oracle-specific. I don't know if other relational databases offer this. It's called Flashback. And unlike most things in Oracle, it's free. I don't understand that. Like everything else in this space that Oracle wants you to use, either they charge you a ton of money for it or they've deprecated so you can't use it. And Flashback lets you do two things. It lets you write two queries. The first query lets you query the state of a table in a point in time. So I have a query over there, select star from student enrollment as of this time. And I'm saying like current timestamp, I think minus 5 milliseconds. So it's going back just a little bit. And it'll show me the state of that table as of that time. So now you can say, well, I don't want to just look at today, so the current state. I can also look at the state as of a minute ago or 5 minutes ago or yesterday, not yesterday. We'll get to that, but some point in time in the past. But it also lets you. Oh yeah. So if we think of our student, we could then query the table as it appeared any of these steps, right? So if we went back 5 minutes ago, we would see that they just registered for organic chemistry. And if we went back 4.5 minutes ago, we would see that they changed their organic chemistry to pass/fail, and we would see the state of the table at that time. Oracle Flashback lets you do something else, which is lets you query events, ways that the data changed over time. So if you select start from student enrollment again, now I'm saying show me the versions between, and I'm using an Oracle syntax there that just says go back as far as you can to the most recent thing. So show me your complete range of history for this student. That's me, by the way. What that will show you is every way the data changed in the time range that Oracle has for you. And it ends up looking a lot like this. And so if we look at this, it has this action column. And the action column is insert, update, delete, IUD. And then it's got the data of the row. And it also tells you how long that version of the row lasted. So this student inserted small group communication, grading method of A and F. And that started, whatever, midnight on the 3rd. That version of the row has never ended, which tells me that that's current state. Then they inserted creativity intelligence, AF, and it started 10 seconds later, and it lasted for 30 seconds. So that is no longer current state, and it was only real for those 30 seconds. Then they inserted organic chemistry, then they updated organic chemistry, they updated creativity intelligence, and then they dropped organic chemistry. Right? And so you can piece this together, and you can see this listing of events, everything that happened for these rows in the database. This is something we've never seen before. And to me, this is basically magic, right? Oracle is now be able to say, I can show you events and state from any time, and put some quotes around any there. And it's fairly straightforward to write queries that then let you see, show me how a column for this one row changed over time, if that's the sort of thing that you're looking at, which we had to do for one of our applications. A con to Flashback is that you can only go as far back as the data is kept, which the U right now is 2 hours, right? So if PeopleSoft were to, or your application were to go down for 2 hours or more, and you brought it back up, you would lose some of that state. Like you wouldn't be able to go back and retrieve it because Oracle has wiped it from its memory. There's some talk within the DBA team of extending that. I don't know what's going to happen there. I make no promises. Not my job. It's just a rumor. You didn't hear it here. Flashback is really good at telling you that a row has been updated. Like we go back to here, that it tells me that organic chemistry did update. But the only way for me to know what actually updated is to compare the two rows. Like there's not a column in Oracle where it says, I updated this row and this is exactly what I changed. You can get that from Oracle. It's called Golden Gate. It costs $1 jillion. So don't expect that on campus. maybe, unless someone comes up with $1 jillion. And this is, again, this is all Oracle only. So if you're trying to do processes outside of Oracle, this probably exists in other databases, but I don't know what it's called. And that brings us to, wait, oh yeah, so that was flashback. That was kind of this a detour into how you might be able to get events out of Oracle using the other stuff. But it kind of brings us to this new idea that with flashback, we're able to see for the first time a list of all the changes to data over time, which brings us this kind of approach that we're starting to play with. We don't have this fully in production yet. This is the one approach that's not currently really running a production system, with the idea of event stream. And if you think of an event stream, it is an immutable log of data, a immutable log of changes to your data state. It's all the events that have happened to your data. And we saw that with flashback, right? This is the student's version of their events, but when we run that flashback query and say, show me all the versions over time, that's the database's version of an event stream. But we know there's a problem with Oracle's event stream, which is that it's only there for 2 hours, right? So what we need is, that's the flashback version of it. What we need is some way of taking that event stream and persisting it somewhere so that we can use it forever. And one of the advantages of using it forever is that anyone who cares about the state of data, like how, say, student enrollment changed over time, if they are able to go back and look at that log of all the events that happened over time, it's there for as long as that log has existed. They're no longer limited by the 2-hour limit that Oracle provides. We just shove it somewhere else and keep it forever. So I'm going to start talking here about a tool called Apache Kafka. Apache Kafka is a big old beast. I'm going to really focus on some aspects of it about basically what Kafka does, and the part I'm going to focus on here is it takes event streams and writes them to logs, which you can then keep forever. Right? That's the relevant bit here. There's a lot more to Kafka. But if we were to take a flashback query that shows us the changes over the last 2 hours, and we were to shove all of that into Kafka, where it is immutable and persists forever as long as you have disk space, then you can just query that event stream and do whatever you want with it. If you want to take that event stream and say, well, I want to keep another database in sync so it looks just like production, yeah, you can do that. Do I want to take something that looks at all those events and say, show me when a student drops a bunch of classes? And now I'm going to alert the advisor. Show me when a student enrolls in a bunch of classes so they can tell the bookstore, hey, order some more books for organic chemistry. Yeah, you can do that. And a nice bit so that data is there forever and can be read as many times as you want is that any number of consumers, which is a Kafka term, can look at that event stream and then make decisions based upon the events that it sees, or just streams that state into a different database. Now here is where I was going to have a demo, but I've got 4 minutes left, so no. I'm going to record the demo at one of the one-button studios, and I'll put it online. But it shows just a very simple process of setting up Kafka and configuring it so that it takes data from one table, shows all the flashback events, streams it into a log that you can query forever, and then puts it somewhere else. And it did actually work. Not just making this up. But let's talk about some of the pros and cons of event streams. So pros gives you basically live state and events. The time it takes from a data change in Kafka, and like say live PeopleSoft, streaming into Kafka into somewhere else is seconds, right? So it's like that bit where we're doing live querying in ETL, where we've tuned things to 5 minutes, we can now drop to seconds. So we essentially have an operational data store that is seconds behind production. And the retention aspect of Kafka lets you retain those events for as far back in time as you'd like, as long as disk space allows, right? And disk space is cheap. The con to this is that Kafka is operationally very, very complex, right? We've got it running across 5 hosts and for dependent resiliency purposes, so it never goes down. And there's a lot of management, and the Ansible playbooks are like this, and I don't really understand some of the stuff. And it's a big beast. There's a lot of stuff behind Kafka. If you compare that to like an ETL process where you write select and you insert, there's a lot more moving parts. But if you look at Kafka event streams and as a metric for success, do you get accurate data? Yes. Do you get event-driven actions? Yes. Do you get resiliency if PeopleSoft is down? Yes. So there's a trade-off there. I want to kind of give a quick overview of this, of the 4 techniques I talked about and how they work with the metrics for success. And yeah, that event stream, super great. A lot of downsides with operational complexity. ETL maybe doesn't give you the freshness, but a lot easier to spin up. The stuff in the middle, kind of in the middle. I'm going to provide a couple of quick further resources, try to have a couple minutes for questions here. If you want to read a book about data, this is the book to read. It really is amazing. In a way, it describes not so much it talks about the technology, but the problems that people are trying to solve with databases and distributed database systems over the course of like 50 years. And then he'll say, oh, and so-and-so invented this in the 70s, and then they tried that again with MongoDB, and it still sucks. So don't do that. MongoDB is probably fine. I don't want to denigrate MongoDB. I've never used it. So, but it's an amazing book. Really highly recommend it. If you don't want to dive into a giant book, there's some really good blog posts on this. The one I turn to a lot, the simplest useful Kafka Connect data pipeline in the world, written by, I think, probably their best blogger in terms of explaining Kafka, this guy named Robin Moffat. Streaming data from Oracle to Kafka, I think that's also Robin Moffat. Ideas for event sourcing or event streaming using Oracle technology, dives into all the different aspects of Oracle that you can use for this, why some cost money, some don't, some of the drawbacks of some of those. And then Confluent, which is the company that makes Kafka, it's open source and free, has a quick start Docker collection of images that I was using for some of my demos, which you'll see later. Okay, so I apparently have 44 seconds left for questions. I'll start back there.
With it being, is this FERPA data being transferred since it's student classes and everything?
Right now, the one place we're using this is, it is FERPA data. The way we've rolled it out for the one approach we're using this in production, one, there's SSL encryption for all the data being transferred. And two, we've locked down the ports and basically only one machine on campus can even talk to the cluster. If we were to roll out Kafka into a larger scale thing, then you introduce the idea of SSL certs and ACL controls, which allows who gets to read what data or write data into Kafka itself.
Great, that was mainly. And I was wondering, so it being complex, how easy is it to update Kafka when new?
I don't know yet, we haven't done it. So, since Kafka is distributed across multiple hosts, right now our QAT cluster is across 5. We should, and we only require 3 for it to be running. We should be able to do 0 downtime updates. And my next goal is to learn how to do that.
The next talk.
Yes. Anyone else? Michael.
Just a quick question about the flashback.
Yeah.
I'm just curious because the one query you showed was against one template, like one primary key field. Does it scale across larger row sets?
So when I started playing with flashback, I reached out to Andy and I said, hey, I'm going to do this. Do you think there's any problems? And he said, I don't know. Let's find out. So we just started doing a bunch of flashback queries in production. And he tuned us to like anything involving flashback. He told Oracle to only allow it 1% of CPU and only if that percent of CPU was available, basically, so that we wouldn't just crush production. And he saw no change. And we've basically been able to run our stuff all the time. And we have some operationally fairly complex flashback queries. Now, I will say the one time I tried to run flashback against all of student enrollment, it basically took 5 minutes and just kind of churned for a really long time. But for the most part, we've been able to run flashback queries without any problems. My understanding is that the way we're doing this stuff, Oracle essentially has everything in memory. So it's not really going to disk to get a lot of things, which slows down the I/O side. But that's a better question for Andy.
So just sort of curious. So you're sort of trying to extrapolate all this information out of the database, but at some point, right, so there's some UI the students are going to, and then there's some service somewhere that is actually telling the database, hey, we're making these changes, right? So, I mean, is there an issue with like getting whatever service is making those changes to like log all those changes somewhere?
Yeah.
I mean, so
that's an aspect we didn't talk about. So what we're talking about there now at that point is database triggers or some sort of logging where the system itself is event sourcing. So we've seen 2 problems there. One, the systems the students interact with are wide and varied, let's say, right? Some of which are under OIT control, some of which are not, some of which are vendored, some of which are not, who knows? So having a consistent logging mechanism out of that very difficult. The other problem we've seen is PeopleSoft does offer some of these things. There's a thing called the student daily audit table, which gives you a list of all the changes that happens to some student data during the course of a day. Which students? Good question. Is it all students now or is it some?
I don't know.
See, and he made the last change to it that I know of.
That's just a
So-
database trigger. And it's
yeah, it's a database trigger. So it's effectively when student data changes, a trigger catches it and writes it to another database table. You can say, oh, this change happened, this change happened, this change happened. But there's a utter opaqueness of what that trigger is, when it gets triggered, or even who manages it. So we've written stuff that relies on things like the daily audit table to get that log of changes, but I don't necessarily trust it. One of the nice things about Flashback or other Oracle tools like that are looking at the change vectors in the database is that they have to report everything. There's really no option for them to do anything else. Because one of the things we're doing with Flashback is querying the undo log of Oracle. That's how it lets you uncommit things. And so if it's not there, Oracle can't do its job. So everything has to be there.
Second, real quick. So your example of the sort of like live query and ETL. So essentially you just built kind of a fancy caching, right?
Yeah,
Is that
I mean,
the-
a materialized view is just another name for a cache. So you hit all the exact same problems you hit with any caching. How do I validate the cache? How do I know if the cache is up to date? It's caching. Caching sucks. But it's the only way to get performance out of a live query approach.
You mentioned trust, I think, in answering Travis's question, and I think, depending on how much you trust the data, it seems like you know, I don't know how often you query Flashback for the events, but if there were a login or network problem, you might miss events if you go beyond 2 hours.
Yep, you would.
Similar to maybe the live query and ETL. Right? Am I thinking about it right? So as you compare that to triggers, I don't know how you'd make that
I
decision.
mean, I'll give you a hint on what I think the
Yeah.
future of this is. It's using either Oracle Golden Gate and paying for it, or we wait until an open source tool called Debezium releases something that can parse Oracle's log mining tools. Because what Oracle does to move data from one database to another is it writes everything to its own internal log. And Debezium, in theory, will take that log, parse it out, and store it in Kafka. It doesn't necessarily work for Oracle yet. But that log between Oracle databases is how data moves between all the different Oracle instances. Like live production isn't one database, it's a bunch, right? So if data changes here, it has to move to this other one so that it keeps in sync. All that gets written to Oracle logs. If we feed that into Kafka, there is at that point basically no way to miss data. But with Flashback and a 2-hour limit, and you don't query for 2 hours, yeah, you miss events. Our Flashback queries run once a minute right now. But if PeopleSoft goes down for 2 hours or our stuff goes down for 2 hours, we lose stuff. Yeah. If PeopleSoft were down, then yes. Mark in the back has a question. We think. God
This is
only
a little
knows.
bit more of just a general comment. All the things that you're doing, including using Flashback, is what the OIT integration team is using to get the common data layer more up to date and build that out. So in the limited time we have here, I'll leave it as a comment. Event-driven data access security is one of our proof of concept work projects that we're doing. And I'll be talking about that on Tuesday at the IDEA meeting, a little bit about the concepts there, if people want to learn more about that. But also just a caveat, if everyone started querying the production data on PeopleSoft at the data level we've got there, I think we'd probably get a lot of different answers and a lot of probably pushback from people. So we're trying to work at making a distinction between data events, which a Flashback does, and business events, which will be something a lot more usable, like a person dropped a class, not this row changed in this table. And our strategy long-term is to provide a publish subscribe access to those business events, which then would be even more useful for that way. And we'd have consistency of the data and probably go to one source that would probably provide a lot more consistency across all your applications. So we're working on it. It's just going to take a while to get there.
And so IDEA on Tuesday, a great meeting. I'm going to try to be there for that too, because I saw that and definitely want to see more about it. I should wrap up. We've kind of definitely gone over. So, but if you have questions for me, I have to run to training, so don't talk to me after this. But Slack is the way to go.